Hello, it's Mrs. Green, and this lesson is going to be on the Pythagorean Theorem. So I've got a couple graphics here. I've got the classic right triangle, and the squares coming off of the right triangle, and the Pythagorean Theorem, a squared plus b squared equals c squared. You've probably heard that sometime in your life, and you might not have known what it meant, and we're going to start using it to calculate lengths of sides of right triangles. You can also use it for other things, but that's where we're going to start. And then I also have a graphic showing a picture of Pythagoras. Pythagoras is an old mathematician. Well, I don't know that he was old at the time. I think of him as old now. So back in the day, we have already seen a couple of videos with him and square roots. He's also responsible for this famous, handy theorem. Okay, so you need to write your prior knowledge. So whatever you already know about the Pythagorean theorem should be in your notes. And that's the part that you are engaging your brain, thinking about things. And then we're going to add the next three parts of your notes: key information, sample problems, and practice problems. And then at the end, you're going to do your wrap-up summary, as always. So let me start with some key information on the next page. All right, the first part of the key information is to draw a right triangle. So here I have my triangle ABC. It's not triangle ABC, actually. It's a triangle with sides A, B, and C. It's a right triangle, so I'm going to indicate it's a right triangle with my little notation, that right triangle symbol. And now I'm going to label the parts of a right triangle. And it's leg, leg, hypotenuse. So here we have a little graphic where the Pythagoras is deciding to call the length of the longest side, sometimes we call it the slanty side, but it's the side opposite the right angle. That side is called the hypotenuse. 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 That's a very long word. That's called the hypotenuse, and the other two sides that are adjacent to the right angle, that form the right angle, are the legs. So we have two legs and a hypotenuse. Those are the parts of your right triangle, and then we're going to use those in a theorem called the Pythagorean Theorem. So the Pythagorean Theorem, I think, is on the next page. Oh, nope. Oops, what happened to my Pythagorean Theorem? I guess I deleted it accidentally, so I have to retype that. So this is the definition of the Pythagorean theorem. If the hypotenuse of a right triangle has length c, so here let's draw a picture. So similar to the picture I had a minute ago where my legs and my hypotenuse were labeled. So if the hypotenuse is c, let's spell that right, hypotenuse. If the hypotenuse of the right triangle has length c, and the legs have a and b length, legs a and b, then we can we know something is true that Pythagoras proved, which is that a squared plus b squared equals c squared. So there it is in words and a picture. So please draw a picture, and algebra with letters. So words, picture, and algebra. And I think we're ready for example problems. Yes, we are. Okay, example problem number 1. Oops, there's my... Okay, so our two problems. Example 1 is going to have two different examples, but the instructions are the same, so, and the triangle is the same. So for the right triangle ABC, which I have drawn in blue here, capital A, B, C denotes the angles in the triangle. That's how we name a triangle. And then the sides are small a, small b, and small c, because those are used in the Pythagorean theorem. Find the missing side length. So part A gives us two lengths. It's going to say that the side length A, so notice that's small a. Small a is 3, and small b is 7. So if I know that my A is 3 and my B is 7, I need to find my hypotenuse of C. So I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared. And they've told me that a is equal to 3, so I'm going to substitute in for 3, for a, the number 3, that is squared. and for B, 7 squared, and that I have to calculate what C is. Remember, I don't want C squared, I want just C by itself. That's the missing side length. But I'm starting out with the Pythagorean theorem. So now I'm going to simplify by squaring 3, that gives me 9. Squaring 7 gives me 49. And then I'm going to continue simplifying by adding 49 and 9. That's going to give me 58. And remember, I'm trying to solve for C, not C squared. So in order to unsquare C squared, I have to take the square root of both sides. So I have to take the square root of 48 and the square root of C squared. 58, sorry, not 48. So the square root of 58 is what C is equal to, and if I wanted to express that in a decimal, which is usually more common than leaving it as in this root form, then I probably would grab a calculator. I'm going to do that right now. And I know it's going to be somewhere between, let's see, 7 would be 49 and 8 would be 64. So somewhere between 7 and 8, you could put that as your answer. Or I'm going to be more specific and put a decimal because I used a calculator of 7.62. And let me check to make sure that's reasonable. So I know that my A was 3 and B was 7, and this is more than 7 and more than 3, which makes sense. 7.62. And it doesn't give me any units. No. All right, so example number 2. Well, that was example 1A, example 1B. All right, here they've given me A and C, so I have to find a leg. So I'm going to use the same theorem, a squared plus b squared equals c squared. Substituting 4 in for a, so 4 squared plus I don't know b. So I'm going to keep using b squared. And substituting in 9 for c. Simplifying this would be 16 plus b squared equals 81. Now I have to use inverse operations, so I'm going to subtract 16 from both sides. B squared is equal to 65, so 81 subtract 16. And that's not a perfect square, so again, I'm going to use a calculator to figure out the square root of 65. And I know it's going to be just a little bit more than 8 because that would be 64. So if I take the square root of b squared, that's going to give me b, which is what I'm trying to solve. And if I take the square root of 65 on my calculator, I read 8.06. So that's the length. Let's make sure it's reasonable. A was 4, C was 9, and B should be less than 9, so 8.06. Okay, that's example 1 and 2. Your practice problems are, so example 1, you were asked to calculate the hypotenuse, which was C. So you added a squared and b squared. In number 2, you were asked to calculate one of the legs, so you had to use subtraction. I had to use inverse operations of subtraction. So be careful. You don't. A lot of students make the mistake of substituting 9 in for b and then squaring and adding instead of subtracting. So be careful. Just don't mix up your letters. They gave you A and C. That means you're calculating one of the legs, which means you're going to use subtraction. So practice problems. All right, practice problems are similar instructions to the 2 example problems. You have a triangle ABC, and they've given you 2 sides. So rather than draw 4 different pictures, we're using the same triangle, right triangle, over and over again. And your missing side length is what you're finding. So for number 1, you have to find C because you're given A and B. Also, that's the same for number 2 and number 4. And then for number 3, be careful because you're asked to find a leg. You're asked to find B. Okay. So then at the end, you're going to do your wrap-up summary. And I'm signing off for now.